Hi, today we are going to finish the review together. And so let's go ahead and open that up. So this is where we left off before. So in case you're just watching this video, how do you know how many total zeros there are? You just write down the highest exponent. So the highest exponent is 5. So by the fundamental theorem of algebra, there should be 5 total solutions. They could be real or they could be non-real. And then these two should add up to 5. The next problem, the biggest exponent is 3. So by the fundamental theorem of algebra, the total number of solutions is 3. Highest exponent is 3. Total solutions, 3. And then we're going to do those two problems, 3, I guess, together. Now going back to where we are. Okay, if that is 5, then the number of real zeros could be 0, could be 2, could be 4. Can't be bigger than 5. Now, the reason why these are even amounts is because non-reals always come in pairs. So how do we know? So the answer could be 0 and 5, could be 2 and 3, or it could be 4 and 1. The easiest way, I think, is just to go graph that. So it's negative 6x plus 2x to the 5th plus 1. And I count 1, 2, 3 solutions. So this would be 3. And so 3 plus what is 5? That would just be 2. So this has to be 2. Okay. Just remember, this number must always be even because non-real zeros always come in pairs. Let's do this one. X to the 3rd minus 4x squared plus 5x minus 20. 1, possibly? Let's zoom out. Oh, yeah, just 1. So it'd be 1 real and then 4 non-real. Oh, wait, the total's 3. So it'd be 1 and 2. 1 real, 2 non-real. So I'd put 1 here and I'd put 2 there because 1 plus 2 is 3. Okay. This number can never be odd. Next one, total 3. Type it into Desmos. X to the 3rd plus x squared minus 16x plus 20. I have 1, and I'll show you the common mistake. Kids go 1, 2, and so then they put 2 here, and then they put 1 here, and that can't be true. That can't be true because non-real zeros always come in pairs. And so there's no way that's true. And the reason why is because you have one solution here, and then this is what we call a bounce. So it doesn't go through, it just touches it. And we count those as twice. So we got 2 solutions here, 1 solution here, 2 plus 1 is 3. So what this should say is all of them are real, none of them are non-real. Write a possible equation for this polynomial in factored form. Well, let's go through it. I have right here a solution. That would be negative 2.5, it looks to be. And then you have to decide, so let me have kind of work backwards. That's the same thing as negative 5 over 2. And then if I multiply both sides by 2, I get 2x equals negative 5. And then if I add 5, I get 2x plus 5. Okay. So if I set 2x plus 5 equal to 0, I get negative 2.5. And then furthermore, it's going to be to the 3rd power because it does what we call like squiggles right here. It doesn't go, see, anytime it looks like that, That usually means to the third power. Here we got a solution there. It goes straight through. That would just be x. Well, that's a z, x. Okay, and then this one right here looks to be at 1. So if it's 1, that'd be x minus 1. Put all that together, and I get 2x plus 5 to the third. And then x, I like to put the x out front, just looks nicer. Remember, order does not matter. And then I can put x minus 1 there. One thing to double check though, and you could always use Desmos and just kind of check your answer and type it in. One thing you want to check is to make sure it's not flipped over the wrong way. Okay, so since it's positive, we're going to leave that as positive 1. If we wanted to make that skinnier or compress it, we could change that number to a fraction or bigger than 1. But yeah, it should be fine that way. So just to check our work, x minus 1, 2x plus 5 to the third. And it doesn't have to be exactly the same. See how this one goes down much more? So, but it's close enough. We don't know what this is, but if I wanted to say bring in the x, the min and the max, I can maybe put like a 1/2 here, or maybe a 1/8. See how that brings the vertex down and up a little bit. But I'm not too worried about that, the stretch and compress factor, so we'll just leave that off, and this is good enough. Okay. So it says, what's a possible equation? There's no way to know the actual equation without knowing the y-axis. We have no idea what this is. Write a possible equation. All right. Well, right here, I got -2. And make x plus 2. Okay. It goes straight through, so x plus 2 is fine. Looks like at -1, it goes through. So I'd make x plus 1. Here, it goes through the origin, and it's a bounce, so that must be x, and it's a bounce, so it's x squared. And then finally, it goes through 2, so that'd be x minus 2. And it goes straight through. Now, putting all that together, I would get y equals, and I'm going to do the lazy man method, x minus 2 times x plus 1 times x plus 2. Don't forget your x. Okay. Now, if I type this in the Desmos, you may notice it looks, I mean, it has the same x-intercepts, except it's going up on the right. We want it to go down on the right. So to flip it over, if we just put in the negative sign right there, it'll flip it over. So let's do that. Put in a negative sign, flips it over, and now it looks way more like the original picture. And so that's what I would go with. Number 11, our last one. We have, looks to be -1. So that would be x plus 1. And it goes straight through. And then we have 1. So that would be x minus 1. And it's a bounce, so we do to the second power. And then we have 2, but it'd be x minus 2. And it's a bounce as well, so it'd be to the second power. And then adding on, this goes down on the right, so we're gonna have to put a negative out front. So putting all that together, I'd get y equals negative to flip it over, and I just need these factors. And the order does not matter. And that's it. And I could type that into Desmos, check my work. I know I'm correct. So that is your review. Please make sure you study it. I hope you have a good day, and I'll see you later. Bye-bye.